Hello, this is Fauzia Maksura, ID 191101167. For this project, we have designed a data logger system where we record the measurements of temperature and humidity. To display the recordings of temperature and humidity, from this DHT11 sensor in this virtual terminal window, the Arduino code is used. My groupmates Mulibak Hussain will run this Proteus simulation, and Naima Ahmed Noob will demonstrate how to embed this Arduino code inside this Proteus Arduino component and how we have used a pair of COM ports to connect the Proteus compin with the LabView Visa, while Farnas Fawad Hassan will further explain the graphical user interface. Let me discuss the Arduino code in brief. As we have used the DHT11 sensor, we have defined DHT11 as DHT type and include the libraries of DHT so that we can use the sensor's functionalities. Initializing the DHT11, we have used the void setup method to activate the sensor and set the baud rate to 9600. The void loop is used to read the temperature and humidity and format it in string. In cases the sensor doesn't give readings, we have used isnone to show the error. So I'll leave the rest to my group mates. Thank you.
Assalamu alaikum sir, my name is Mumalik and I'm going to explain the Proteus part and the LabView frontend. So in the Proteus we have used an Arduino UNO R3 as a microcontroller. Along with it we have used a DHT11, a virtual terminal, a COM port, a 5V power supply, ground, and a resistance of 4.7 kilo ohm. The 5V power supply has been attached to the number 1 pin of the DHT11, ground is attached to pin number 4, and the TX and RX ports have been attached to the TX and RX ports of the COM port. TX goes to TX, RX goes to RX, and the TX has been attached to the RX of the virtual terminal. In the Arduino board, we have imported the hex file that was generated earlier. Now if we run the Proteus software, we can see a virtual terminal box has been generated, which shows the value of the temperature and humidity from the DHT11. If we increase the value, if we decrease the value, we can see the values have been updated, and if we increase the values, we can see the value will be updated as well. We can also select the temperature. Now if we increase the value 28, we can see 28. So as we can see, the Proteus is working fine. Now we will move to the LabView part. The LabView portion has the temperature sensor and the humidity as a meter. We have also used two charts, temperature chart and humidity charts for the above mentioned devices, and we have also used a table that has date, time, humidity, temperature, and ID. We can also see the block diagram of the front end: temperature, humidity, temperature chart, humidity chart, and the table. Thank you.
Hello, I'm Farnas Hassan and I'm picking up from where my last teammate left. Now, before moving on to creating the COM port part, we first rearrange the temperature and humidity modules. We place a clear command here and attach an open command beside it to open it. The clear command is placed here to empty out the buffer before starting. Now, for reading the two strings, temperature and humidity, we place two read commands. We use a flush command to flush out the visa and use a close command to close it. The close command will be used to clear the data. We also placed an error handling command to handle errors, if any. This whole thing will be inside a while loop, and then we connected all the then we ensured proper connection between all these commands and also ensured that these are properly connected with the while loop. Now, this thing right here is the Visa resource constant, and it has been put here to control the COM port. We then created a time delay and set it to 500 milliseconds. Now, to transform the strings to numbers, we used two string to number arrays, array converters. We attached an insert into array command with the table control, and we added shift registers to shift the values after one loop. We connected everything with the string and array constants. Now the array will update and produce an updated output. We connected all the data lines with the respective modules and and fed them into the array. After converting, uh, these two lines right here are the date and time. The next two are the temperature and humidity, and the last four are our IDs. We will also have to ensure that this loop condition will always have to be false to ensure proper working of this. Now we run it, and since we're not having any errors and this is also working properly, I think we're good to go for our final demonstration.
Hello, my name is Naima Ahmed Noop and I'm going to present the demo of the whole project. First, we turn on the virtual serial port where we pair two ports COM1 and COM2 which isn't currently in use. Now anybody can send and receive data from COM1 and COM2. After that, we need to compile the code in Arduino and copy the link of this hex file. Now in Proteus circuit, double-clicking the Arduino and our hex file from the code is uploaded here which we previously copied. And here in Compin, we have to select COM1 and we're working with 9600 for physical and virtual bandwidth. After that in LabView part, this is our project data logger system and this is the backend of our data logger which was explained by my teammate. Here we need to select COM2 in Visa resource name which is the output part of comport, and we already selected COM1 in Proteus. Now let's play this one. We can see we are receiving data, and in Proteus we have to turn on the simulation. In this virtual terminal we can see the data, and in this table we can see the value. First we will show the changes in humidity data. I'm decreasing the humidity and we can see the changes in this gauge and also in this waveform chart. Now I'm increasing the temperature and we can see the real-time changes from this table. So we can always see the latest value here. And that's all. Thank you everyone.